In this video, we're going to start exploring how we can combine exponents and working with exponents. If we look at a simple generic form of an exponent, x to the m, the x is the base of the term, and the m is the exponent. And it's very important to remember the distinction between the two, because this will tell us how we can actually combine exponents. So if we have x to the m and we're multiplying that by x to the n, the rule is we put the base down and we add exponents. So if we had 2 to the 4th times 2 to the 3rd, that'll be 2 to the 4 plus 3, which equals 2 to the 7th. If we have 3 to the 4th times 4 to the 3rd, we can't combine these because the bases are not the same. So we'd have to just leave them as exponents or calculate the exponents and then multiply. The next type of feature we can do with exponents is when we take an exponent to a power. So if we have x to the m and the whole product, the whole exponent is being taken to the nth power, then we multiply exponents. So if we had x to the 6th and we're raising that all to the 10th, that'll be x to the 6th times 10, which is x to the 60th. If we have something inside, a number for instance, let's say x, 3x cubed, y squared, and z to the 4th, and we're raising that to the square, then we take each component and we will apply that exponent. Now you see I'm writing these down. As you become more comfortable with these, you will find that you will do a lot of this in your head. So 3 squared is 9. X to the 3rd, raise that to the power of 2, so that becomes 3 times 2, so that becomes x to the 6th. The y squared squared, 2 times 2, so we have y to the 4th, and then z is 4 times 2, so we have z to the 8th. And that's all we can do with that simplification. Another component we can work with is division. So if we take, for instance, x to the m divided by x to the n, then we simply subtract. So if we have a to the 3rd over a, that's a to the 3rd minus 1, because really this exponent, if we leave it off, is 1, and this becomes a squared. We subtract. If we had x to the 10th, y to the 3rd, z to the 8th, all over x squared, y cubed, z to the 4th. We're going to subtract these, so the x becomes x to the 10 minus 2, which is 8. The y is really y to the third minus third, which equals y to the 0, and anything to the 0 power is 1. So we'll just leave it off. It basically cancels off. And then the z, 8 minus 4 is 4. So that would be the simplification. If we have x to the minus exponent, then convention says that we should write it and switch its position in the fraction. So if we had, for instance, x to the minus 3, this becomes 1 over x cubed. We get rid of the minus. If we have, let's have another little rule here. Let's say we have negatives in both the exponent and, both negative exponents in the numerator and the denominator. So we just flip those. So if we had a to the minus 6 over b to the minus 8, we place those in the different position of the fraction. Now you want to be careful. Let's say we have x to the minus 3 over y to the 4th, z to the 6th. All we need to do is move the exponent that has a negative. We leave everything else where they stand. So this becomes 1 over x cubed y to the 4th, z to the 6th. If we had one more, a to the minus 6, b to the 4th, all over c to the 10th. The only thing we need to worry about in repositioning is that a minus 6, a to the minus 6. So that becomes b to the 4th, all over a to the 6th, c to the 10. If we had a base that was a known, so for instance 2 to the minus 3, that'll be 1 over 2 to the 3rd, and we can simplify that as 1/8. So just a little review. If we take x to the m times x to the n, we add exponents. If we take an exponent or power to a power, we multiply. If we take exponents and divide them, then we subtract. And then if we have a negative exponent, we write it as a fraction. Basically, whatever is a negative goes either from the numerator to the denominator or the denominator to the numerator. And be aware of the x to the minus m over x to the minus n. They just change places. And they're only changing places because of that minus. If I had, again, x to the minus m over x to the positive n, the x to the n would stay in its denominator. So that's how we work with exponents.